Hello everyone. In this video, I will be discussing the fourth and fifth learning objectives of week 8, a discussion and analysis of variance and interpreting analysis of variance results. If you have watched the last two videos, I have discussed chi-square test and t-test, and in this video, I will be discussing ANOVA. Just I try to relate these three discussions so that you can understand that when you should use which statistical test. Just to remind you again that chi-square test will be used when you are comparing the observed frequency and expected frequency of two variables and both the variables are nominal scale variable. T-test will be used when you are comparing the difference between two variables and both the variables are ratio scale, interval or ratio scale, or you are comparing one interval or ratio scale variable between two groups, then you will use t-test. Now, when you should use ANOVA, analysis of variance. Analysis of variance will be used if you compare the mean of more than two variables. If you compare the mean of multiple variables, then we use analysis of variance. Or if we compare the mean of multiple groups of a particular variable, we also use ANOVA. For example, let's say you are comparing customer satisfaction, average customer satisfaction of different income level. Okay, let's say you have 5 income level 1, income level 2, income level 3, income level 4, and income level 5. Now, there's an average customer satisfaction of income level 1, 2, 3, 4, 5. You are comparing if there is any difference between average income level of average customer satisfaction of these income levels. Then you will be using analysis of variance. Okay, if you compare the average customer satisfaction for different age groups, and you have, let's say, 4 or 5 age groups, and you compare the customer satisfaction for these different pair of age groups, you will be using analysis of variance. The condition for analysis of variance in terms of the measurement scale is same as that of the t-test. For example, analysis of variance can be used when you have interval or ratio scale variable, or you have interval or ratio scale variable grouped on the basis of a categorical variable. So what we actually do is when we calculate ANOVA statistic, we first calculate the variance between groups, then we calculate the variance within groups. Okay, so what we are actually talking about, as I said, that you have let's say that you have an interval or ratio scale variable and you group or you categorize it into different groups. Okay, so if you have customer satisfaction and you have an average, that is your grand mean. And if this customer satisfaction is divided into 5 age groups, for each age group, you will have one mean. That will be group mean. So when we calculate between group variance, what we actually do is the difference between the group mean and the grand mean. That means the mean of a particular age group and the mean of the entire sample. That is the variance between group. And we also calculate variance within group. So what we do for each group, you understand, for each group, there will be a group mean. And within the group, there are individual observations. So we calculate the variance between individual observation and the group mean. Okay, so once we have this variance between groups and variance within group, then we run an f-test where the numerator is the variance between groups and denominator is the variance within groups. And by running the f-test, what we try to find out is if there is a difference between the mean of this pair of groups. And as usual, the answer we get will be a p-value, and p-value is compared with the significance level, and we decide that whether we accept the null hypothesis or reject the null hypothesis. By this time, we already know that if p-value is greater than the significance level, we accept the null hypothesis, and if p-value is less than the significance level, then we reject null hypothesis. A simple example. Here is a coffee consumption response for 3 shifts: day shift, second shift, and night shifts. So you have 5 observation in day shift, 4 observation in night shift, second shift, and 5 observation in night shifts. So basically you have 3 groups like day, second, and night. So you want to find out that if average coffee consumption is different between day and second shift, or second shift and night shift. Okay, so what you have is a mean for the day shift, mean for the second shift, and mean for the night shift. Now if you calculate a mean for this entire sample, then it is your grand mean, and for each of this group you have a group mean. So first we calculate the variance between grand mean and this group mean. This 4 is your grand mean and group mean. Then for each group, for example, your mean is 2, but it has individual observation 1, 3, 4, 0, 2. So we calculate the variance between this individual observation and group mean. So what we get is within group variance. So first one was between group variance, then within group variance. Look at this. So this is the day shift, this is the second shift, and this is night shift. So the overall mean is this one, and this is the day. This is the morning shift. As morning shift has an average, you compare with the overall mean there, and this is the day shift. Its average is compared with overall mean, and this is night shift. Its average is calculated with overall mean. So we get between mean variance. Then this morning shift has an average, and individual observation is compared with the average. That is the within group variance. So once we have this within group variance and between group variance, then as I said that we calculate F statistic and look at the p-value to see that if the null hypothesis is accepted or rejected. For example, here null hypothesis was average coffee consumption in morning shift is same as the average coffee consumption in day shift equals to the average coffee consumption in night shift. That means average coffee consumption in these 3 shifts are same. Now if we look at the result, look at the F statistic. I mean, this is the overall F statistic and significance. This is basically the p-value. This p-value is 0.03, so it's less than the significance level. That means 0.05. So we reject the null hypothesis. So when we reject null hypothesis, it means that we accept our alternate hypothesis. That means the null hypothesis that there is no difference between the average coffee consumption across the shifts is rejected. So there is actually a difference between the average coffee consumption across the shifts. Okay, and if we carefully look, that mean for day is 2, mean for second is 4, and mean for night is 6. That means there is a significant difference between the average coffee consumption of these 3 shifts. Okay, so when we interpret your results, you should provide a statistical interpretation that this is the p-value, this is less than or greater than the significance level, so we accept our null hypothesis or reject our null hypothesis. So that's the statistical interpretation. And non-statistical interpretation, you should write that the mean of this variable is this, mean of this variable is this, and mean of this variable is this. So there is a significant, they are not same, and there is a significant difference between the means of these groups. So this is the end of this video. I will strongly recommend that you carefully solve and understand the workshop questions this week, because those are very much related with some of the questions in your assignment. So understanding this lecture and the workshop activities will help you solving your assignment too. Thank you very much.